Welcome to the first day of Intro to Polynomials. So first we need to talk about the vocabulary. What is a polynomial? A polynomial is an expression with more than one term that contains non-negative integer exponents. For example, 3x squared plus 2x minus 5 is a polynomial. But as soon as you make it 3x to the negative second power, that is not a polynomial. We want our exponents to be positive. Also, 1 over x minus 5, fractions, not polynomials. Neither are square roots. If you have the square root of x minus 5, not a polynomial. Standard form is a polynomial arranged with the terms so that exponents are in descending order. In other words, you start with the largest exponent and you work your way to the smallest. That's why we do x squared, then x to the first, and then the constant. A leading coefficient is the number in front of the first term when the polynomial is in standard form. Be careful, because sometimes they will give you something like negative x, let's say negative 2x to the third plus 5x to the fourth plus x minus 7. The leading coefficient is not negative 2. I don't care that it doesn't come first, or rather that it does come first. What I care about is that it's not the term with the largest exponent. In this case, the term with the largest exponent is 5x to the fourth. So my leading coefficient is 5. So please remember, your leading coefficient has to be put in standard form first. The degree is the largest exponent and the polynomial is in standard form. So again, my degree of this last example would be 4 because it is the largest exponent out of the entire equation. If you were to put this in standard form, the 5x to the fourth would come first. Let's talk about identifying the degree of a function. In standard form, the degree of the function is the largest exponent. Your largest exponent is 3. So I have a degree of 3. Again, be careful, because if it's not in standard form, you need to put it in standard form first. Let's talk about factored form. The degree of the function is the sum of the largest exponents of each factor. So on the left, standard form is when you're adding or subtracting everything together. On the right, factored form is when you have parentheses, right? A factor is x minus 1. The other factor is x cubed plus 4x squared plus 4x minus 1. You're going to find the largest exponent in each set of parentheses. In my first set of parentheses, my largest exponent is 1. In my second set of parentheses, my largest exponent is 3. So my degree is 1 plus 3. This is a degree 4 equation. Now, your exponents can also be on the outside of the factors. In my second case, the largest exponent of my first group is on the outside, 6. Of my second group, also on the outside, 4. So my degree is 6 plus 4. This is a degree 10 polynomial. Take a minute to pause the video and answer these two questions on your own. So in the first example, it asks for a leading coefficient of 7 and a constant of 6. Remember, a constant is a term with no variables. In this case, our only constant that has a 6 is choice 4. It also has a leading coefficient of 7, which number 2 did as well. but we're going to go with 4 because it has the proper constant. In number 2, which of the following polynomials does not have a degree of 4? Well, for choice 1, the largest exponent of each section is 2 plus 2. That gives me a degree of 4, not your answer. Number 2 is in standard form, so my largest exponent is 4, not my answer. I have an exponent of 1 in my first group, an exponent of 2 in my second group. This one has a degree of 3. If you want to know why 4 is not your answer, an exponent of 1 in your first group, exponent of 3 in your second group, it has a degree of 4. Let's talk about more vocabulary. A 0 is when the graph touches the x-axis. It's also called an x-intercept, a solution, or a root. They're all synonyms for each other. Multiplicity is a new word. It's the number of times a polynomial has a root at a given point. Remember, we discussed how sometimes answers could happen more than once. So when we're solving equations, sometimes we get x equals 2 twice. That's because x equals 2 has a multiplicity of 2. And tangent, you might remember from geometry, it's something that touches at a single point without crossing over. For example, a circle and a line here are tangent because they touch at one point. Now let's look at the graph. At the first graph, we have a linear equation, and where it's circled, this is our 0. It's also our root. So we're going to write x equals -3, right? That's where we're crossing the x-axis. Now, a possible equation for that, if our 0 is at -3, the factor is the opposite, x plus 3. Now let's talk about multiplicity. If you go straight through the x-axis, it's a straight line, it has a multiplicity of 1, which means that x equals -3 happened one time. So my exponent is 1, which is not necessary to write. The degree of my function is 1. For the next one, when you hit the x-axis, kind of at a U, it is a multiplicity of 2. It is tangent to the x-axis. It bounces off of the x-axis. We call it a bouncer. Now the 0 is at x equals 0. A possible equation is y equals x minus 0 or plus 0. But because we had a multiplicity of 2, we're going to make an exponent of 2. If we simplified this, you might recognize this as y equals x squared, a parabola. The degree of the function is 2. When you hit the x-axis at a squiggle, it's called a multiplicity of 3. It flattens out before crossing the x-axis. And our term for it, which is not the technical term, is squiggle. So our 0 is x equals 1. If x equals positive 1 is the 0, then x minus 1 is your factor. Now this had a multiplicity of 3, so your exponent is going to be 3. And it has a degree of 3, which makes sense because this is a cubic function. should have a degree of 3. You might notice that the second one and the fourth one look similar. They kind of are, but the difference is that this one is more noticeably flat, right? It's not exactly tangent, it flattens out a bit. So that has a multiplicity of 4. It's tangent to the x-axis, but flatter. Our 0 in that case, if you look really carefully, is x equals negative 4. If x equals negative 4 is your 0, then your factor is the opposite, x plus 4. Can you guess what the exponent's going to be? It's going to be the multiplicity of 4, with your degree being 4. Now, you can use the less technical terms of straight through, bounce, and squiggle, or you might notice that multiplicity has the shape of the degree of the function. For example, when you're going straight through, that looks like a linear function, which is a degree 1. When you're tangent, that looks like a quadratic function, which is a degree 2. When you have a squiggle going on, squiggles look like cubic functions, which is a degree 3, so a multiplicity of 3. If that's confusing for you, just use straight through as 1. A bouncer is multiplicity of 2, and squiggles multiplicity of 3. I'll be honest, the multiplicity of 4 doesn't happen as often, but it's still good to know. So turn back to the do now, and these are the 2 equations that we solved in the beginning. The only difference is that now I also have the graphs with them, and we're going to analyze it for a bit. So all of these are our solutions, right? And if you noticed, the solutions are also your x-intercepts slash roots slash zeros, right? All mean the same thing. And each solution happens one time, which means each solution has a multiplicity of 1. And a multiplicity of 1 means that you should head straight through. So if you look at the graph, what's happening is you have 4 x-intercepts because you have 4 solutions. And each solution is going straight through the x-axis because it all has a multiplicity of 1. That's different in the second equation. In the second equation, you have 3 distinct solutions. So those 3 distinct solutions means there's going to be 3 distinct intercepts. But if you noticed, sorry, the solution of x equals negative 1 happened twice. So let's look at our x-intercepts. Right? We have 3 different intercepts. This one goes straight through. This one goes straight through, which makes sense because they both happened one time in our solutions, right? X equals 5 happened once. X equals 1 happened once. But this guy is bouncing, which means it had a multiplicity of 2. And you could tell it happened twice because of the exponent there. X plus 1 happened twice. It's x plus 1 times x plus 1. So this x equals negative 1 happens twice. It's a multiplicity of 2. So that's how it affects our graphs. The shape changed there. If you're still confused on it, let's try a few examples. So we have two x-intercepts here, right? The first one, what shape do you think it is? I think it's a bounce at x equals 2. That means x equals -2, that solution happened twice. Or you'll see it in an equation as x plus 2 squared. Our other x-intercept goes straight through at x equals 3, which means it has a multiplicity of 1. This would be x minus 3. It happened one time. A possible equation for this graph could be x minus 3, which happened once, and x plus 2, which happened twice. Let's go on to the next one. Try to see if you can figure out all of the multiplicities for each x-intercept. We have a bouncer, a straight through, and a squiggle. The bouncer means it has a multiplicity of 2. That's going to be x plus 3 squared, because you take the opposite for the factor. The straight through is a multiplicity of 1. X plus 0 to the first, or just x. And the last one is a squiggle at 4, so you're going to have x minus 4 to the third. A possible equation for this graph is y equals, put them all together, x plus 3 squared times x minus 4 cubed. Try the next one. I see two x-intercepts, a bouncer here, a squiggle there. At my first x-intercept, it is tangent. In other words, it is a bouncer. It has a multiplicity of 2. At the other one, it is a squiggle. It flattens / passes through. So it's a multiplicity of 3. Can you get what the possible equation will be? The possible equation is x minus 2. And remember that had a bouncer, so that's going to be an exponent of 2. And the other factor is going to be x minus 4 with a multiplicity of 3. So now you can tell it that this is a degree 5, right? Because 2 plus 3 equals 5, right? Let's try the next. Pause the video, complete this on your own, and then resume it to see if you got it right. So the question is asking you to classify each 0. Remember that another word for 0 is x-intercept, or roots, or solutions. And I see 1, 2, 3 x-intercepts. So my first x-intercept is at x equals -3. And at x equals -3, I am bouncing. If you're bouncing, that is a multiplicity of 2. Let's move on to the next one. At x equals 2, I have a squiggle, which is a multiplicity of 3. The last one is x equals 5. This is straight. Totally ran out of room. It says straight through. And straight through is a multiplicity of 1. So write down the possible equation. If you don't have a y equals or an f of x, it's not an equation. You lose a point. So I put a y equals. You could put an f of x. I'm going to take my 0, turn it into a factor by using the opposite value. So we're going to have x plus 3. My multiplicity is 2. That's my exponent. My next one, x opposite of positive 2 is negative 2. My multiplicity is my exponent. The last one is x minus 5. So the first. You do not need to have the exponent of 1. It's up to you. So that is a possible equation. And look, if you make your t-chart, you get back all of your zeros. So you know you're on the right track. And if you graph this, you'll see a similar image. Now, what degree could this polynomial possibly have? You could get it 2 ways. 1, 2, 3. Your largest exponent of each factor. Add them up. You have a degree of 6. The other way you can get it is by adding your multiplicities, which would be the same exact thing. 2 plus 3 plus 1, you have a degree of 6. So, how are multiplicity of the zeros related to the degree of the polynomial function? Well, you add the multiplicities to get the degree. That's all for this video.